so we're going to look at some trickier questions now. This sort of thing, they really love putting these in, so I'll just explain to you how to go about it. So it tells you you've got 5 cubes here of side length 1 centimetre, and so we're going to get the surface area of the solid. Alright, so if you have a look at this, here are the 5 cubes. 1, 2, 3, 4, 5. And they've been stuck together to form this thing. They've been glued together. Okay, so if we look at just the area of 1 square, doesn't matter which square, right? So the area of 1 square. And it says that the side length of the square is 1 centimetre. We've got 1 centimetre and it's a square, so all the sides are equal, remember? So it's 1 centimetre squared. Area equals S squared, 1 squared, that gives you 1. Now I've written units squared there, but they did say it was centimetres squared, so we'll fix that up. Okay, now, that's the area of 1 square. Now we've just got to work out, these are all going to be the same area, all these little squares. We've got to count how many of these squares we have. Now, if we have just 5 cubes and they're sitting separately to each other, then we would have 5 cubes. Each one of them has 6 faces, right? So if we times by 6 faces, we would have 30 faces altogether, right? But these are not sitting separately to each other. They've been glued together. So when you glue 2 faces together, right? So when 2 things come together and get glued, I'm trying to find something I can look at to show you. Just a minute. Okay, so I have 2 books here. Now, if I glue these 2 faces together, right, what I've done, if I'm then going to paint around the whole thing with these 2 bits glued, then these 2 surfaces here are not painted. All right, they're glued together. They're not included in the surface area of this whole shape because they've been glued together. They are, if we're going to paint it, they will not get any paint on them. So what we're actually doing is eliminating 2 surfaces when they are glued together like that. Okay, so let's see where they've glued. So we know they've glued there. So those 2 are glued together. So you've got 2 surfaces that are gone now. Then we've got another lot of glue happening here. There's another 2 surfaces not included. Then we know, I can't show you the whole thing, but we know that it's glued in there as well. So those 2 squares aren't included. And then we know it's glued again here. Okay, so we've got 1, 2, 3, 4 lots of glue going on. And that's 4 faces times 2 not included if we were going to paint this thing. Alright, so if we multiply that out, we've got 8 faces not included. So, if we have 30 faces, take away 8, that means we have 22 faces that will get paint. Okay, so now the total surface area will be those 22 faces times 1 centimetre squared for each face. So our total surface area that would be painted if we were going to do that is 22 centimetres squared. Okay, so they're a bit tricky, but when you glue them together, there's 2 things that you're being eliminating. Okay, now this next question, they love putting this one in. It's a swimming pool. They've marked it, it's got 15 metres long and it's 10 metres wide. Okay, so some of those sort of smaller learn to swim pools might be like this. The depth of the water ranges from 1 metre to 3 metres. So that makes sense if you think about a pool, if you think about your local swimming pool, your 50 metre Olympic pool. It has a shallow end, 1 metre, where you can stand up. And then if you try and walk down the pool, it gets deeper and deeper and deeper, and this one gets to the deep end at 3 metres. Okay, so the first thing they're doing is asking us to calculate the area of the floor of the pool. Alright, so the floor of the pool is that part where you start off and it's here, and you start walking and it gets deeper and deeper till you can't stand up anymore. So that's the floor of the pool. Now it's a rectangle, okay? I'll just put a big red mark around it, but this is a rectangle. Okay, so we're going to find A equals LB for the area of that rectangle down the bottom there. Now, the length of that, this bit here, say, is the same as that. So that's 10 metres. You can write it on with your red pen. So that's 10 times by, now the breadth is this bit. And nobody has told us what that is. So let's just call it X for the time being. We have to find that. All right, so how are we going to find X? So we just move to the side here. This is a harder question. So I'm just going to move it to the side and you can watch what I do. So I'm going to draw the diagram of the front face. All right, so our front face looks like this. Okay, we have 3 metres here. And this bit, if you look, bring that forward, that's 1 metre. And that bit there, if you bring that forward, is 15 metres. And what we're trying to find is X here. So, to do that, we are going to draw a dotted line across there and create a right angled triangle down the bottom here. Okay, now, the 3 metres is this whole length, and the 1 metre is this length. So how big would this bit be? Well, that's going to be 3, take away 1, which will give you 2. Right, so in there, you've got 3, take away 1. So you've got a 2 in there. And that bit there is going to be the same as the top part, so that's a 15. So we have a 15 and a 2 that we're working with in our right angled triangle. So it looks like this if we break it down. And we're looking for X. So we're going to use Pythagoras' theorem and go and find out what's going on here. So let's sub in everything that we know so far. Okay, and we're going to work that out in a minute and square root the answer and get what we get. Okay, so I'll just quickly work that out on the calculator and see what we end up with. So we're doing 2 squared plus 15 squared. And that equals 229. And then we're going to square root the 229. And we will get this. Do not do any rounding. All right, so that's your X value. So when we come over here to do the area for the floor of the pool, we've already got the length done, that's 10. Now we're going to multiply by that number that we just found. I'm running out of room here, so I'm just going to write the rest of it down here. Now when we multiply it by 10, you'll get that answer there. All right, now that's the area of the floor of the pool. Now the next part says find the total surface area of the pool. Now you've got to use your common sense here. If you had a pool, an in-ground pool, and you were going to paint the surfaces of the pool, you would not paint the top, right? There's water there. People want to be able to dive in and swim around. There is no top. You're not painting a top. They're not going to tell you that in an exam. They want you to know that by common sense. So we don't have a top here. So we did have a floor of the pool, but we don't have a top. Okay, so we're going to find the other surfaces now. The floor's been done. We have no top, so let's do the rest. The front area. Now, you can see the front area. I've got it up there now. We're doing the area of a trapezium for that one. Okay, so the area of a trapezium formula, you need to know it, is a half h bracket a plus b. So when you're putting your numbers in here, I always put the a and the b in first because the a and the b are the parallel sides. That's the 2 vertical sides. So I'm going to put my 3 plus 1 in there. Okay, now the h, the perpendicular height, joins from between the 2 parallel sides. So that's your 15. So that goes in there. Now put that into the calculator exactly as it says it. A half times 15 times bracket, 3 plus 1 bracket equals, and it'll give you a 30. Now that's the front area, and if you look at the back, It's got the same trapezium at the back, so you don't have to do it all again. It's exactly the same. In fact, this shape here would be called a trapezoidal prism because its base shape is a trapezium. Okay, so now we're doing the right area. That's this one here. It's a rectangle. Remember, all the rest are rectangles. So it's length by breadth, and it's easy to see it's 10 times 1. So you're going to get 10 there. Now the left area is this one over here. And that's pretty easy. They've got 10 times 3 over there. And that'll give you 30. Now we can do our total surface area. So remember, there's no lid. So we're counting 5 surfaces, not 6. So we need 5 numbers. 1 is the bottom of the pool that we found in part A. That's 1. Then we've got 2, 3, 4 and 5 all done just then. Add them all up and you get your final answer. So if it said what's the area that you're painting, that would be the answer. Okay, so have a go at these for homework. You do need to know every step of the working like I've been doing. Don't leave any working out.